Hello students, today's video lesson is Unit 11, Lesson 10. We'll be covering pages 384 and 385 out of the textbook. As always, I hope you are all well. Before we start our work in the textbook, I just wanted to kind of recap our paper plate. We will be adding just a few more things to it on tomorrow's lesson. All right, but this is very important here. I can't emphasize enough the Pythagorean identity, which says that for cosine theta squared plus sine theta squared equals 1. That is true for any angle. Remember, when we're on the unit circle, if we have a point xy on the unit circle, then the x-coordinate is equal to the cosine of the angle, and the y-coordinate is equal to the sine of the angle. If we have a point that is not on the unit circle, right, on our blue circle, is not the unit circle, then the sine of our angle is equal to y-coordinate over the radius. The cosine is equal to the x-coordinate over our radius, and the tangent is equal to y over x. Let's not forget our signs, S-I-G-N, S in quadrants. Right, in quadrant 1, we have all for all of our trig functions, sine, cosine, and tangent are positive in quadrant 1. In quadrant 2, sine is the only one that is positive. In quadrant 3, tangent is the only one that is positive. And in quadrant 4, cosine is positive, right? All students, S being for sine, take T for tangent, chemistry, C for cosine. So today's lesson, we're going to reinforce what we already know, and that is that tangent. That tangent of theta is equal to y over x. So we're just getting some practice in with tangent today. So in the textbook, on page 384, the tangent function. The two most important trig functions are sine and cosine, but recall there's also our third trig function known as tangent. So recall our SOHCAHTOA. Sine equals opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So we're already familiar with this. In fact, if you would please just write it down again. The more you write it, the more it's going to help you memorize it, commit it to memory. So tangent, TOA, is opposite over adjacent. In relation to the angle theta here of this right triangle, this side is opposite, and this is the adjacent side. And of course, this is the hypotenuse. So putting this into practice, for each of the right triangles below, state the values of sine theta, cosine theta, and tangent theta. Well, the first thing we need to do is find the missing leg in 1A. If you know your triples, I know I've mentioned that before, triples, Pythagorean triples are 3, 4, 5, and any like multiple of that, like 6, 8, 10 would be a triple. Also 9, 12, 15. But the other common Pythagorean triple is 5, 12, 13. These are Pythagorean triples. So in this case, if a leg is 4 and the hypotenuse is 5, then the other leg is 3. This would have to be a 3, 4, 5 Pythagorean triple. You don't have to memorize them. It's good if you do know them, but you don't have to because you can always use Pythagorean theorem. So in this case, I would say leg squared of 4 plus other leg squared equals the hypotenuse 5 squared. So 16 plus b squared equals 25. Subtract 16, b squared equals 9. Square root both sides, b equals 3. So we want the sine, cosine, and tangent. So sine cosine, and tangent. SOHCAHTOA. So sine of our angle theta here in this right triangle is opposite over hypotenuse, 3/5. Cosine is adjacent over hypotenuse, 4/5. And tangent is opposite over adjacent. So you can try B if you like. This is not a triple, so you would have to use the Pythagorean theorem to figure out what this leg here is. But this would be the side opposite in relation to angle theta. This is adjacent and hypotenuse. So again, if you want, pause the video, find the length of this leg that's opposite theta using Pythagorean theorem. So the square root of 3. So sine of angle theta in this right triangle is square root of 3 over 2. Cosine of theta adjacent, that's 1/2, and tangent opposite over adjacent, square root of 3 over 1, which is equivalent to square root of 3. Just recall also that you are never going to get a sine value that is greater than 1, nor would you get a cosine value that is greater than 1, right? Because sine is opposite over hypotenuse and cosine adjacent over hypotenuse. So your hypotenuse is always your longest side of your right triangle. So you would never have a sine or cosine value that would ever be greater than 1. Okay, and then we're looking at what sine is equivalent to when we have a unit circle. So when there is a missing side of a right triangle, use the Pythagorean theorem to find the third side. Sometimes this is a radical and thus is an irrational number. Just as with sine and cosine, we can also define tangent in terms of the unit circle. And we have already done this. So this is simply reinforcing what we have already done. We already know that tangent, when we're on the unit circle, is equal to sine over cosine. But here we're just putting it in our notes on paper. So consider the unit circle shown below. Answer the following questions based on the diagram. So here we have a diagram of the unit circle. Right? We know it's a unit circle because this length right here is 1, so it has a radius of 1. If x comma y represents a point on the circle, how can we define the tangent function in terms of this point? Well, tangent we know is TOA. So tangent of theta is equal to opposite over adjacent. In relation to theta, opposite is our y, and adjacent is our x. Here's our right triangle. Same as what we had on our red unit circle. Right? We have our SOHCAHTOA, and we said that tangent was y over x. So this is equal to y over x. Given how we define sine and cosine, how can we define the tangent function in terms of sine and cosine? Well, when we are on the unit circle, we know that the x-coordinate's the cosine of our angle, and the y-coordinate is the sine of our angle. So that's where we get that tangent theta is equal to sine over cosine. Again, this is something else you have to memorize. And that takes us to its definition at the top of the next page. The tangent function defined in terms of sine and cosine, right? Tangent theta is equal to sine theta over cosine theta. We are omitting exercise 3. Exercise 4, because tangent function involves division, there's a chance it could be undefined, meaning we would have 0 in the denominator. Consider the angle theta equal to 90 degrees, which is equivalent to pi over 2 radians. State the values of sine and cosine of this angle. Okay, well, whenever I see a quadrantal angle, an angle that is a multiple of 90 degrees, I always think of drawing the unit circle. So I draw an x and y axis, and then I just plot the 4 points of our unit circle and write their coordinates. This would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. 90 degrees would be here. State the values of sine and cosine at this angle. All right. Well, the sine is the y value. So the sine of theta of 90 degrees is equal to 1. And the cosine of theta, which is 90 degrees, is equal to 0, the x value. Right? Sine is the y, and cosine is the x. Why would the value of tangent 90 degrees be undefined? Because tangent of 90 degrees is going to be y over x, or sine over cosine, which would be 1 over 0. And we would have 0 in the denominator. So 0 in a denominator is undefined. Exercise number 5, at which of the following angles is tangent undefined? Okay, so we have 0, 270, negative 180. These are quadrantal angles. The 120 is not. I'm going to draw a larger 4 points of the unit circle. And oftentimes I'll just mark the 4 points. I will not actually draw this circle because it just seems to get a little messy for me. Okay, so 0 degrees. The tangent is undefined when the denominator is 0. So when the cosine value is 0. The cosine value of 0. Remember, our x-coordinates give us the cosine of our angle. So 0 degrees, our x-coordinate is 1, so that's a no. 270 degrees, which is here, that has an x-coordinate of 0. So that is our answer, option 2. Remember, negative 180 would be the same as a positive 180, would have an x value of negative 1. Number 6, if we know sine or cosine of an angle and the quadrant of the angle, we can find the other two missing trig values. Determine the value of cosine and tangent theta if sine theta is equal to 5/13 and the terminal ray of theta lies in quadrant 2. All right, so there's two ways of doing this. We can use our Pythagorean identity, or we can draw a triangle in the quadrant. So I'm going to say Pythag identity, or draw a right triangle in quadrant 2. I'll just say Q2. So I'm going to do the right triangle first. So the sine of our angle is 5/13, and the terminal ray of our angle lies in quadrant 2. So in quadrant 2, I draw a right triangle. Sine is opposite over hypotenuse. So opposite is 5, hypotenuse is 13, and this is a triple. This is a 5, 12, 13 triple. Again, let me just go through using Pythagorean theorem, which would say 5 squared plus b squared equals 13 squared. That's 25. Subtract 25 from 169. Square root both sides, so b is 12. So now use SOHCAHTOA to find cosine and tangent. So cosine is adjacent over hypotenuse, which in this case is going to be our 12 that we just found, over 13, but we are in quadrant 2, where cosine is negative. So our answer would be negative 12/13. And tangent of theta is opposite over adjacent. Opposite is 5, adjacent is 12. Again, we are in quadrant 2, remember, where tangent is negative, so it would be a negative 5/12. The other way we could do this is to use our Pythagorean identity, and which is cosine squared theta plus sine squared theta equals 1. Take our value of sine of theta, which is 5/13, put that in for sine theta, and solve this for cosine theta. That's 25 over 169. If I subtract that from 1, all right, or actually I'll just use the calculator. Hopefully it will show up this time. I'm just going to subtract 5/13 squared from both sides. So I'm taking 1 minus 5/13 squared. Trying to get it so it will at least show up here. It's not working for me. Okay, well, I math frac that and then square root of it. That's 144 over 169. There's a little bit of it. And the square root of that's 12/13. So we have that cosine of theta. Sorry, all that work was done on the calculator. Cosine of theta is equal to 12/13. All right. So from here I got cosine squared theta equals 144 over 169. So we finally have cosine theta is 12/13. Now to find tangent of theta, well, we know tangent simply sine over cosine. So I'm going to go in this direction to find tangent. So we know it's sine is 5/13 and cosine is 12/13. But before I forget, let me not go back to cosine of theta and say, oh, we're in quadrant 2 where cosine is negative. So cosine theta is a negative 12/13. And now tangent theta equals sine over cosine, which would be 5/13 over negative 12/13. The 13ths divide right out, so our answer is negative 5/12. So really what I'm getting at, again, this can be done either way, all right? Given that you have the sine of the angle and the quadrant in which the angle lies in, you can draw your right triangle in that correct quadrant and find the other trig values using SOHCAHTOA, or you can use the Pythagorean identity to find the cosine of our angle and then find the tangent by taking sine over cosine. Now the last problem for this lesson is number 7. If cosine of theta equals a, where a is greater than 0 and the terminal ray of theta lies in quadrant 4. Okay, so we're in quadrant 4. Then which of the following gives a value of tangent theta? Well, in quadrant 4, tangent is negative, all right? And cosine is a, and a is greater than 0. So we have to figure out, well, we know that tangent is equal to sine over cosine. So we have cosine, that's equal to a. Well, what does sine equal then? If I use the Pythagorean identity, which says that cosine of any angle squared plus the sine of any angle squared is equal to 1. And if I replace cosine of theta with a, we've got a squared plus sine theta squared equals 1. Subtract a squared from both sides. Let's put it over this way where it belongs. So we have sine theta squared equals 1 minus a squared. And then we take the square root of both sides, so sine theta equals the plus or minus the square root of 1 minus a squared. But we are in quadrant 4 where sine would be negative, right? Sine would be negative. So I go back to here, tangent theta would equal negative square root of 1 minus a squared over the cosine value, which is a. That's our answer, which is option 4. Could I also have done a triangle? I could, right? I could have done a triangle in quadrant 4. Try to sketch one out quickly. Cosine of our angle is a, so that's adjacent would be a, and that would be a over 1. The hypotenuse would be 1. And then I could say, okay, a squared plus b squared equals 1. Subtract a squared. And b equals the square root of 1 minus a squared. And then if this is the square root of 1 minus a squared, and then tangent is opposite over adjacent. So the square root of 1 minus a squared over a. But just remember you're in quadrant 4 where tangent is negative. Okay, so this concludes this video. So your homework is page 386 and 387. All the questions on that page, but omit number 1. So you are not to do question number 1 on page 386. All right, so this is page 386 here. So just bring this down. Omit that. Do not do that. If you have any questions, if you have questions on homework that you're working on or homework that you did, please send a post to me in Teams, or you can, I think in the class Teams would be better. This way, if there are several questions on the same problem, then maybe I can just do a video of that problem. All right, so any questions you have, just send a post in Teams if you would, please. Okay, thanks very much and have a wonderful day.